Before we begin hacking, let's set up our environment. Start by opening the terminal and navigating to the directory where the application is stored. Before that, let's increase the font size by pressing Ctrl plus Shift and a plus sign a few times. Now type cd 10 minutes hack juice shop and press enter. Next, run the command npm start. After a few seconds, the app will be up and running. Looks like we're ready. Now click the Firefox icon to open a browser. In the address bar, type http://juiceshop3000 and hit enter. Everything works fine. Now, using the Foxy Proxy add-on we configured earlier, select the Burp Suite proxy. All your traffic will now go through the proxy. Click the burp icon to launch it. Loading will take only a moment. And here it is. Click through the startup prompts. Next, and then start burp with the default settings. Wait a few seconds, and we're in. Head over to the proxy tab and select HTTP history. Then, go back to the browser and click the refresh button to check if everything works. It should be ready in a moment. Now, if we return to burp, we'll see new requests appearing in the HTTP history. Awesome! We're ready to hack. To exploit our first vulnerability, we first need to log in. Click the Account button, and then select Login. Since this is our first time interacting with the Juice Shop application, we need a user. You can use the test account we've prepared. Email is user@10minuteshack.com, and the password is very secure pass, written in leet speak. You can copy these credentials from the video description. Feel free to create your own account. But keep in mind that due to Juice Shop's database self-healing feature, you might need to recreate it after every restart. Now let's log in using the test user 10minuteshack.com email and the special password. Everything here looks like a typical online store. Select Account and click on the email. Here's the account management panel. If you go back, take a look at the left pane. There's a hamburger menu where you can find another store-related functionalities like customer feedback or support chat. And of course, there are various products to buy. Let's start by adding a product to the basket. I'll choose carrot juice. A confirmation pops up at the bottom of the screen. Now scroll up and click the Your Basket button to check its contents. As expected, there's 1 carrot juice in your basket. Let's switch over to Burp Suite to inspect the requests. We're interested in the GET request sent to REST Basket 6. Right-click this request and choose Send to Repeater. The Repeater tab will light up. In Repeater, click Send to replay the request and view the response. As you can see, the response body includes the basket ID, 6, and the user ID, 23. Below that, under Products, we see our carrot juice. Now let's try changing the basket ID in the request URL from 6 to 0. Remove the digit from the URL and type a new one. Then click Send, and there are no products returned, but the server still responds with a 200 OK and a success message. So, what do you think? What will happen if we try ID 1? Change the ID and click Send, and this time we get a completely different basket. It includes someone else's basket ID, user ID, and a list of products: apple, orange, and egg fruit juices, none of which we added. See that? We've just accessed another user's basket by exploiting a horizontal broken access control vulnerability. Back in the browser, you'll notice a green notification at the top. Challenge solved. View another user's shopping basket. Nice. Now let's fix this vulnerability. Stop the server by pressing Ctrl plus C in the terminal. Next, open VS Code, and since you're already in the project directory, just run code space dot and hit enter. That will launch VS Code right with application code loaded. Make the window full screen. Then, in order to make the code easier to read, press Ctrl and plus to increase the font size. Now let's locate the vulnerable code. It's in root/basket.ts. Type this path in the search bar and click on the first result. Before editing, you can also enable line wrap by pressing a combination of Alt plus Z. Now scroll to line 17. The vulnerable code is marked with a comment. In the retrieve basket function in lines 18 to 25, you'll notice that there's no check to verify if the basket belongs to the currently logged in user. First, there's an ID variable retrieving data from the request parameter and simply uses it in the find1 function as a part of the where clause. Later, in line 23, there's a user variable created as a reference to the currently authenticated user. However, there's no code responsible for checking which basket ID should be accessible for a specific user. Let's fix that. We'll start with commenting out the old code, from line 18 to line 25. As you can see, the secure version of this functionality is already written. Simply uncomment the code starting at line 27 and again at line 44, and let me explain what this fix really does. First, it still gets the basket ID from the request. Then, it assigns the authenticated user to a variable, just as before. The key part is on line 34. It compares the basket ID from the request with the one stored in the user session. If the user tries to access a basket that isn't theirs, the app returns a 403 forbidden error on line 38 with an appropriate message. Press Ctrl+S to save the changes. Then open the terminal window again and use the command full restart to see our fix in action. This might take a while. The recording was edited a little bit to speed things up. After the restart completes, go back to the browser and close the challenge notifications. Then, click the account button and log out. Later, log in again to start a new session. Let's use the saved credentials for our test user to log in and repeat our steps. Start with adding a product to the basket. I'll stick with the carrot juice again, why not? Click Add to Basket, then view the basket. Looks fine to me. In Burp Suite, go back to Proxy tab and HTTP History and locate the request to REST Basket 6 endpoint. Then, just as before, send it to the Repeater tab. To take a closer look, click the Send button. And yes, we get a 200 response with the correct basket content. Same as before, good. Last time we changed the ID to 1 that let us view another user's basket, but now, 403, access denied. Nice work. We've successfully mitigated the horizontal broken access control vulnerability. The second flaw lies in the account registration mechanism. Let's start by logging out and navigating back to the login page. Choose Account and Logout and Account and Login, then click the Not Yet a Customer button. Now fill out the registration form with any sample data. I'll just use some dummy placeholders for testing. What you put here, it really doesn't matter. After entering all the required data, click the Register button to finish the process. Great! The new account is created. Now we're going back to Burp Suite to investigate what really happened under the hood here. Click the Proxy tab to see the HTTP history. The request we're interested in is a POST request to the API/users endpoint. We need a closer look. Use right-click to send this request to Repeater. As you know, Repeater makes it very easy to analyze. If you look at the request body, you'll see that the user sends several parameters: email address, password repeat, and a security question with its answer. Let's hit the Send button and analyze the response. Oops, an error. Well, that makes sense. A unique email address is needed to register a new account. We'll fix that right away. In the server's response, some data submitted by the user is returned in the response body, for example, the email address. But we also see additional fields we didn't provide: ID, username, and role. It looks like a potential mass assignment vulnerability, when the attacker is able to overwrite parameters that should only be controlled by the server. Let me demonstrate it for you. The most interesting parameter here is role. By default, it's set to customer. The application does this automatically. But what if we include this parameter ourselves, the same way we send the email and password? Gotta find out. We'll modify the original request slightly by adding a role parameter with the value admin. After applying the changes, click the Send button. Think for a moment. What could happen now? And it looks like the attack was successful. The server responded with 201 created, and in the response body, we can see that our newly created user now has the admin role. That's huge, from an unauthenticated user to a highly privileged admin account, just like that. So how is this possible? Let's open VS Code to investigate. You may close the basket.ts from the previous bug. This time we're looking at the server.ts file. The vulnerable code is located around lines 383 to 389. John, you can include the line number in the search if you want, by using a colon. As you can see, this section is completely missing any mechanism to prevent parameter tampering. Exactly what we just exploited. There's no restriction at all. What we need here is the code that ensures users can only set the parameters needed to register, nothing more. The fixed version is already in the file, in lines 391-401. Uncomment that code and let me walk you through it. The first part, from line 391 to 393, adds a simple console log. It's just there to inform us about a potential attack. That's not really a mitigation. The key fix is in lines 394 to 401. Here, we explicitly assign values to only the allowed fields: email, passwords, and the security question. All other attributes, like the user role, will be assigned internally by the app securely. without any way to override them from the outside. Save your changes with Ctrl+S. Then stop the server, Ctrl+C, and restart the application using the full restart command you already know. Then, we'll wait for a while. Remember that in the recording, there's some editing magic happening. The restart might take a little longer in your machine. And we're ready. Since this request doesn't require authentication, we can just go back to the same request in Burp. Click the back arrow to reset it to its original form. Let's test the registration again, just to confirm everything still works. Put a new mail, click send, and let's see. Yep, no issues. We're good so far. Now let's test the fix. We'll change the email to a unique one and add the role parameter set to admin. Give me a few moments to do that. We're ready, so let's resend the request. And success! But not for the attacker, for us. The server created the new account ignoring the injected role parameter and assigns the default role customer. Remember about the console log we added in the fix? If we check the terminal now, we'll see the message we added. It notifies us that someone tried to exploit the vulnerability. Fortunately, the vertical broken access control issue is now fully patched.